Hi, hello, very good evening, one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep. And warm welcome to the series GATE AIMERS 2022. Join the session quickly and mark your presence. We are in day 19th of this wonderful series, very useful series. Let me invite Nishu Kumar, Shubham Nayak, Rohan Raj to the session. Those who have joined the session, my request to all of you is please invite all your friends for this very useful session so that they will also benefit out of this session. So we are in 19th day of this series GATE AIMERS 2022, as a part of which we are discussing revising the concepts of programming and data structures, and today's topic is very important topic, very frequently asked topic in the GATE exam, that is pointers and arrays. Shubham Nayak, just by attending these classes, cracking the GATE exam will be easy when your practice also adds to it. Your practice also should be added, then definitely you can not just crack, you can definitely get very good rank. Okay? All right. So I want every one of you to please invite all your friends for this live session. Shall we start the session, guys? I want response from everybody. I want response from everybody, please. Shall we start the session? Shall we start revising this very important topic of programming and data structures, pointers and arrays? Yes? जोर से बोलो. Yes, very good, very good. So let us start without any delay. Firstly, what is an array? Yes, sir, it is very popular definition. Array, which is collection of similar data or homogeneous data. Perfect. And what are different types of arrays? We have basically two types: single dimensional array or one dimensional array and multi-dimensional array. One dimensional, multi-dimensional. Under multi-dimensional we will get two-dimensional, three-dimensional, four-dimensional and so on. What is the other name for one-dimensional array? One-dimensional array is also known as vector. And what is the other name for two-dimensional array? Matrix. Three-dimensional array, you may say cube. Four-dimensional array, five-dimensional array. Accordingly, you can call with other names. Right? Now, it can be 1D or 2D or 3D or ND array. How to identify elements of the array? To identify elements of the array, what we use? Index. Index is used to identify elements. And generally indexing starts with what? By default, indexing starts with 0. And it is not mandatory. You may start from 1 also or some certain number also, but by default indexing starts with 0. Right? Now, when the array is stored in the memory starting from some address, that starting address of array is called what? What we call the starting address of an array as? Base address. What guys? Base address. Right? Now, what is the advantage of an array? What is the advantage of an array or advantages of an array? I can say arrays have an advantage of what? Random access. Any element you can access in the array because there is a index for every element. And what else you can say as an advantage? Array's advantage. Contiguous memory space works like an advantage in some cases as well as a drawback in some other cases. So, under drawbacks of an array, you can say contiguous memory space even under advantage also. And what else you can say as drawback of an array? Insertion and deletion is difficult, or I can say it takes much time when you compare with other data structures. And what else you can say as a drawback of an array? Static memory allocation, or the other term we can use for this is compile time memory allocation. Right? Compile time memory allocation. Now, whenever you take a two-dimensional array, how the two-dimensional array is stored? 2D array is stored in the memory in two ways. Can anyone name them? Row major order and column major order. Row wise, if it is stored, we say it as row major order. Column wise, if it is stored, we call it as column major order. Simple. And accordingly, you can calculate address. Isn't it? Fine. Now, if I wanted to calculate for one-dimensional array, let A be array. Okay, let A be the array and N be size of each element. And B be base address. And let I is index of the element. Then how I can access address of A of I? That is base address plus index multiplied by N when index starts with 0. If index starts with 1, you can say I minus 1 multiplied by n. Isn't it? Okay. In the same way, if I want for 2D array, let R be number of rows, C be number of columns, and I is row index, J is column index. So now you tell me how I can access address of A of ij in row major order, and how I can access address of ij in the column major order. Come on guys, quick, you don't have all the time. Please, I want response from everybody, please. Quick. From row major order, how I can get the address of A of ij, and from the column major order, how I can get the address of A of ij. I am waiting for your response. Yes, it is base address plus row index into number of columns plus column index multiplied by size of each element. And if it is column major order, it is base address plus j into number of rows plus row index into size of each element. And this is when index starts with 0. If index is from 1, base address plus I minus 1 into C plus J minus 1 whole multiplied by N. If it is a column major order, it is base address plus J minus 1 into R plus I minus 1 whole multiplied by N. So if you remember these formulae, it would be very easy for you to identify, to calculate the address of any required element. Perfect. Now let us move on to pointer. What is a pointer? We say it is a variable which hold address of another, usually everybody say address of another variable, but no, address of another data item. This data item may be another variable, may be another pointer, may be an array, may be a function, may be a structure, may be union, may be file, or any other. So pointer need not to store address of a single variable. Even it can hold address of group of variables as array or structure, or the starting address of some subroutine function, or address of a file also. Isn't it? Alright. So how we declare a pointer? Using asterisk operator, as you say data type, asterisk or star operator, pointer name. And what is the advantage of pointer? Firstly, dynamic memory allocation or runtime memory allocation. And the second advantage is indirect access. Indirect access is the other advantage of pointers majorly, right? And these pointers we have several types, as void pointer, null pointer, dangling pointer, huge pointer, far pointer, near pointer, wild pointer, and so on. Isn't it? Okay. Fine. But today's context is pointers and arrays, if you use combinedly, how they work. Let's see firstly with pointers and one-dimensional array. I am taking array as X of, let's say, 5 elements, which is initialized to 10, 20, 30, 40, 50. And I am taking a pointer P, and I say P is equal to address of X. Okay. Let base address be 1000. And one integer takes 4 bytes. Okay. Now there are 5 elements in the array X. They are initialized to 10, 20, 30, 40 and 50. And the indices are 0, 1, 2, 3, 4. And the first element address is 1000. The next element address would be 1004. Next would be 1008 and so on. And what will be stored in P? The base address. The base address. So P will be pointing to the base address. Okay. So now my point or my question is, when I say X plus 2, what would be X plus 2? Listen carefully. The array name itself is equal to pointer when it is 1D array. 1D array name itself is address, means it's a pointer. So 1000 is X plus 0, 1004 X plus 1, 1008 X plus 2 and so on. So what is X plus 2? 1008, which is equal to P plus 2 also. So even you say P or P plus 0, P plus 1, P plus 2, P plus 3, P plus 4, even then you get what? The same address. So let us generalize. Pointer P plus some index I is equal to array X plus some index I is equal to address of X of I. That is also equal to address of I of X. X of I of X doesn't make any difference. Doesn't make any difference. Right? I am talking about one-dimensional array, dear friends. If it is a 2D array, that is a different case. That we will see. Okay? In the same way, guys, what is X of 1? Which is the value at X plus 1, that is 20. X of 4, that is 50. Instead of X, if I say P of 1, that is also 20. P of 4, that also gives 50. So if I generalize this, X of I is equal to P of I. So P plus I is X plus I. X of I is P of I. So can I say X is equal to P? That means 1D array is equal to pointer always. One-dimensional array is always equal to pointer. Right? Okay. Friends, if this session is interesting for you, if you are enjoying this session, please do share it as much as possible. Invite your friends. Let us share this enjoyment to all your friends. Okay, don't forget. Now let's see how pointers work when you combine with 2D array. Okay, let us suppose I am taking 3 rows 4 columns 2D array and I am giving the values as 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Okay, and I am taking a pointer P. Here again I say P is equal to address of X. Right? Now please pay attention. I am having 3 rows, 4 columns, and the values are 5, 10, 15, 20, so on. Let base address is 1000. Okay, guys, see, so what is the address of this particular element? 1000. This 1004, 1008, 1012, and so on, 1016, 20, 24, 28, 32, 36, 40 and 44. These are the addresses. Now, can I say 2D array is collection of 1D arrays? Yes or no? Definitely I can say. So now we know the row index starts with 0, column index also starts with 0. Now guys, when I say X, what is X? Base address. What is X? Base address. That is equal to what? X plus 0. So what is that X plus 0? That is also base address. But here X plus 0 is a 1D array. X is 2D array. X plus 0 becomes 1D array. X plus 1 becomes a 1D array. X plus 2 becomes a 1D array. You have to understand this. X is a 2-dimensional array. X plus 0 is a 1-dimensional array. X plus 1 is another 1-dimensional array. X plus 2 is another 1D array. Means X is having rows and columns, but X plus 0 is a complete row. X plus 1 is a complete row. X plus 2 is another row. So what would be X plus 0? Starting address of 0th row, which is 1000. What would be X plus 1? Starting address of 1th row, that is 1016. X plus 2, starting address of 2nd row, that is 1032. Okay. Now listen carefully. So when I say X plus I, what it is giving? Address of ith row, isn't it? Address of ith row. Okay. Now carefully listen. What if I say star of X plus I? Star of X plus I. What actually it means? Value at ith row. But does row has only one element or multiple? Multiple. Now this is becoming a pointer to array of 4 elements in our example. As per our example, 4 elements. So it is not a pointer to single element. Now what this is? Pointer to whole array. So this also gives what? Address of ith row only. So you can say X plus I is equal to star X plus I when X is a 2D array. And you can replace P, pointer P, in the place of X. X and P can be interchanged. In the same way, suppose I say X plus I plus J. What does this mean? See here. Suppose I say X plus 1 plus 2. X plus 1 indicates what? 1th row. In that, plus 2 means what? X plus 1 means what? 1th row. And any array starting name, any array name itself says base address. So it is 1016 plus 2 into size of each element is 4. That is what? 1016 plus 8, 1024, which is that particular row second element. I mean the element with index column index 2, that address, not value, isn't it? So when I say x plus I plus j or star x plus I plus j, what I get? Address of x of I j. Now if I say star of star x plus I plus j, what do I get? Or first you tell me this. Star of x plus I plus j, if I write, what I get? What I get if I just write star of x plus I plus j? Quick. If I say star of x plus 1 plus 2, this will give value or address? This also will give address only. This also will give what? Address only. No, Daniel. This also will give address only because it is a one-dimensional array. When you get value, when you say star x plus I plus j, then you will get x of ij. Okay. So please do remember all this. They will be helpful in solving questions on pointers and arrays. No, Nishu, it works with 1D array, not with 2D array. Okay, so before we proceed for the questions, these are the courses on our BYJU'S Exam Prep for 2022 as well as 2023 aspirants, and you will get everything in terms of live classes, practice questions, study notes, full length mock tests, daily quiz, weekly quiz in our courses, in every course. And you can switch from one batch to another batch, one course to another course. You can access all the course classes unlimited just by enrolling for this online classroom program. Also, you can attempt all our full length mock tests with this subscription. So if you have any queries, you are free. Feel free to call us on this number 9650052904. Our team will be happy to assist you and clarify your doubts. And we are the team of computer science faculty, Mr. Murli sir, myself, Mr. Satish sir, Mr. Navneet sir and Mr. Anshul sir. We will be handling the classes of all these courses. Okay, now Let us have some previous GATE questions on this pointers and arrays concept. Look at this question, which is a 2019 GATE question. Just 2 years ago, we have got this question. See this. Consider the following program. The number that will be displayed on execution of the program is 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 1, 2 and 5. The indices are 0 to 12 and the array name is ARR. Now pointer should point to ARR plus 4. What is ARR plus 4? This one. So IP is pointing here, and then what would be IP of 1? This would be IP plus 1. So what is IP of 1? That is equal to value at IP plus 1, that is what? 6. If you know it, it is very easy. Otherwise, it would be confusing. Right? Next question. Yes, please. 2019 question is here. Chandan, don't give the answer as you remember it. Solve it now. We are having an array with the values 2, 4, 6, 8 and 10. And the array name is A. The indices are 0, 1, 2, 3, 4. And where B is pointing? B is pointing here at A plus 4. Okay. Now we are having a variable sum, initially 0. Now there is a loop which runs from 0 to 5. So it runs when I is 0, when I is 1, when I is 2, when I is 3 and when I is 4. When I is 0, sum is equal to sum plus star B. What is star B? Value at this B, which is 10, minus 0 minus star of B minus I. B minus 0 is nothing but B. So 10, this is what? 0 plus 10 minus 10, which is 0 again. Then I becomes 1. Sum is equal to 0 plus star B, 10 minus 1 minus star of B minus 1. What is B minus 1? The address of A of 3. So what is the value at A of 3? 8. So this becomes 9 minus 8, 1. Then I equals to 2. Sum will be 1 plus 10 minus 2 minus value at B minus 2, that is 6. So this is 1 plus 8, 9 minus 6, 3. So sum becomes 3. Then I equals to 3. Sum is equal to 3 plus 10 minus 3, minus value at b minus 3, that is 4. 3 plus 7, 10 minus 4, that is 6. And finally, sum I equals to 4, sum is equal to sum plus star b minus I star of b minus I, value at b minus 4, that is 2. So this is 6 plus 6 minus 2, that is 10. So what is the final value of sum? Very good. Everybody has given correct answer, that is 10. Super. Great guys. Great going. Good. Next question. 2011 GATE question is here guys. What does the following fragment of C program print? Char C is GATE 2011, char star P equal to C, print star S, P plus P of 3 minus P of 1. We are having the string as GATE 2011, and we know every string by default will have a terminator, that is null character. Now P is pointing at the base address. Now we want P plus P of 3. What is P of 3? E minus P of 1. What is P of 1? A. So what is this E minus A? ASCII value difference. So actually it is computed in this form, 69 minus 65. So this is P plus 4. Now this is what P plus 4, and we want the string from that particular address onwards. So what will be printed? 2011. Right? Next. See this question. 2015 GATE question is here. What is the output of the following C code? Assume the address of X is 2000 in decimal and integer requires 4 bytes of memory. X of 43 is given, X plus 3 star of X plus 3 star of X plus 2 plus 3. We have 4 rows, 3 columns, and the values are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Addresses, starting address is 2000, so it would be 2012, 2024, 2036. And this would be X plus 0, X plus 1, X plus 2, X plus 3. I told you X plus I and star x plus I will give what? Address of x of I, means ith row address, that is 2036. So this will be 2036, this will be 2036. And we have star of x plus 2 plus 3, like star of x plus I plus j. What does that will give? That is address of ith row plus j into size of each element, that is 2024 plus 3 into 4, that is 2036. So this also will be 2036. So all will print 2036. Got it? So that is what we can say pointers and arrays for today. We will see in the next class. We will discuss another important topic in this GATE AIMERS series. I hope you have enjoyed this session. You have revised this pointers and arrays concept with this session. If so, please don't forget to like the session, share it, and subscribe to our BYJU'S Exam Prep channel. Okay? Thank you so much for attending my class. See you in the next class. Till then, have a great time. Good night, everyone. Take care. Bye-bye.